Hello everybody, and welcome back to Coffee Break, the show where we break down interesting topics all within the time it takes you to enjoy a few cups of coffee. As always, my name is Clifford Swartz, and today I'm going to be joined by Diane Tossetti. How you doing, Diane?
I'm doing great. Thanks for having me.
Always,
I even
of
have my
course.
coffee.
Nice. I have my mug right here. Not filled with coffee. Anyway,
Nope.
Diane is our FPGA marketer, and today we're going to be saying hello to FPGAs. But before we do that, I'm going to throw it over to Wayne Freeman, and he's going to tell you guys how to participate. How you doing, Wayne?
I'm doing wonderfully. How are you today?
10 out of 10.
Nice,
So good.
nice. I'm really excited to hear what you and Diane are going to discuss. And actually, we have so many people in the chat.
How many?
Everybody's checking in. So look, just YouTube alone, we've got just over 100 people over here. We've got quite a few people on LinkedIn. We're also on Facebook Live. People coming in from South America, coming in from North America, Europe,
all over.
India. I mean, honestly, like all over. So hello, everyone. You can chat, ask questions. Please ask as many questions as you would like for Diane. We're going to hold them until the end of the live stream after basically she's gone through her discussion on FPGAs. But this is your opportunity to basically discuss things with an expert. So please like, share, subscribe to this channel, help us build it. And I've taken up too much time already, so I'm ready to get started. How about you guys?
Absolutely. And if we don't get to your guys' question, make sure to email us at livestream@microchip.com.
Sorry, I forgot that.
You're good.
I was just
it's
too
cool.
excited.
Don't worry about it. Me too. Anyway, Diane, so our audience may not be the most familiar with FPGAs. So do you mind talking to us a little bit about what an FPGA is and why somebody would want to use it?
Sure. Whole purpose of today's coffee break is to, give the viewers a chance to say hello to an FPGA.
Ah.
And, very familiar with ASICs. ASICs are very costly. They take an organization, specialized tools, a long, time to get them to market. So an FPGA is great when you want to have that ASIC-like functionality. You want to have custom functions. Maybe there's no, specific off-the-shelf product that's available that you need. You want to integrate multiple functions. An FPGA is really like a Swiss Army knife. So think of it that way. A lot of flexibility and a lot of integration can happen with an FPGA.
Cool. So where would we actually see FPGAs used in electronic systems?
I brought a couple slides to help the audience. Yes, I did. So let's go to that first slide and we can talk about a couple typical use cases. So a lot of times there's components that can't talk to one another on a board. And so an FPGA does a really great job of bridging components from one block to another. Sometimes there needs to be some type of pre-processing or even acceleration that happens. FPGA is great there. FPGAs are great at doing, interface and transport. So, if you want to connect to a backplane or if you want to have an image sensor and then have something on the outside like a display, an FPGA is great connecting things around a board. One thing that's unique about Microchip's FPGAs is that we're non-volatile. So, we can actually do a live at power up system control. So if you want to do system initialization or sequencing, that can be done with one of our FPGAs. And in fact, our FPGAs have a feature that allows these FPGAs to be used in a secure boot function. So you can securely boot other devices on your design without fear of side channel attack. So lots of cool use cases.
Nice. So, at least for me, it's been many years since I did a deep dive into FPGAs. It's been 2 years since I graduated college. Do you mind breaking down what areas we're going to be seeing explosive growth with FPGAs in?
Yeah, FPGAs are absolutely exploding in a lot of different areas. Where we at Microchip are seeing a lot of growth is in an area called smart embedded vision. So think about the fact that cameras are absolutely everywhere.
Everywhere.
We've got everywhere. We've got cameras on our cars. We've got cameras on our phones. We've got drones with cameras. A lot of the industrial 4.0 environments have cameras everywhere. We're using lots of cameras in diagnostic equipment, so medical vision. And what is kind of consistent with all of these different types of products is there needs to be a small form factor enclosure. Mm-hmm. They need to have multi-protocol support. They need to support high power and thermal efficiency. A lot of these need to have high-speed interfaces and require high data throughput. And when they're compute intensive, they need to have a lot of robust DSP and memory resources. So lots of these products also want to become more intelligent. Right. So a lot of these types of products are wanting to add real-time decision-making or decision-making based on some type of visual or sensor input. So an FPGA is great in that type of application.
And so when you say that, we're sort of getting into AI, right?
Correct.
Right. And so what makes an FPGA so good for an AI platform?
Glad you asked that question.
Me too.
AI has been typically done, sorry for the wiggle, has been typically done in the data center. And so what we're seeing now is a trend towards making the edge more intelligent, making the devices, like your refrigerator, more intelligent. And so we call that inferencing. Once the algorithms and the frameworks have been built out, you can do inferencing on one of these edge node types of devices. So edge devices and inferencing platforms, FPGAs are a great fit there. Again, I already talked about, compute intensive applications, but, we have integrated and flexible hardware. Low power dissipation, again, brings us greater thermals. So we can fit in harsh environments. We can, be in really small form factor environments. Because we're an FPGA, that makes us upgradable in the field. Cool. So, as you continue to develop your algorithm or your framework, you can then continually upgrade your product, which is something you can't do, with a fixed function device. We can also integrate a lot more functions. So an FPGA has all this flexibility, and you can also do a lot of integration with the FPGA. So kind of a multi-personality device.
Nice.
Great choice for inferencing.
Absolutely. So we've talked about why it's such a perfect match and why it's a good solution. What are some of the challenges that an embedded engineer who's going to be developing a system that's low power and inferencing is going to face?
Right. And so those embedded engineers are facing these problems now because the frameworks and the algorithms and the training is really done by data scientists and network engineers. And so, these types of models are built out in the software domain. And there is a specialty, that is required to develop these types of models, frameworks, and algorithms. So when you're asking the embedded engineer to then put that on a low power, thermally elegant platform, there needs to be some type of conversion from those network languages into RTL, right, and into a model that the FPGA can then be programmed on. There's also, this might not be well known, but you have many different framework options. There are multiple frameworks and multiple types of neural networks that are all deployed simultaneously in a system to do inferencing. That's how we evaluate and learn how the machine is constantly doing machine learning. And so that might be a custom implementation or a custom framework or a custom performance metric for each one of these models. So you got to have a lot of flexibility with these frameworks and models. More importantly, a lot of this hardware is very expensive. So you have to enable a way to validate that model and your framework is doing what it's supposed to be doing before investing in expensive hardware. So we have a platform, development platforms that can help you do that, before you actually build out a prototype. These challenges are pretty big, and Microchip has identified that making that leap into an inferencing low power, platform isn't as easy as one might think. So we recently announced a product.
What did we announce?
It's called Vector Blocks. Good question. We announced the Vector Blocks Neural Network Accelerator, and it is a development platform. It is, some soft IP, and really what it's going to do is help those embedded engineers, those FPGA designers who don't have that data scientist background and who want to create these platforms make the leap in a very efficient way.
Cool. Thank you. So where do you recommend an embedded engineer get started?
I love it. The whole topic today is say hello to FPGAs,
You said the
and
title.
we have I said it 3 times, I think, hopefully, because we have a product out there that is now available, and it's called Hello FPGA. And this is a low-cost platform that includes a camera board, an LCD display board, as well as a main processing board, all built off our SmartFusion 2 SoC. And this is a low-cost board. It's about $150. It has a very simple GUI. It has a lot of functionality just built in, including artificial intelligence. So, with this board out of the box, you can start measuring power. You can, manipulate the DSP functionality with control logic. You can also, do digit recognition.
Nice.
So this is a really cool platform to get started. If you're interested, you can go to our website at microchip.com/hello FPGA. If you'd like to get on, a mailing list to learn a little bit more, you can send an email to hellofpga@microchip.com. And I want everybody out there to be on the lookout. We're going to have some additional, live streams and webinars around this topic. And we're also going to be hosting hands-on classes. So I hope you can join us for some of those, which will be offered globally in your local language if you prefer. So lots to look forward to.
Cool. Well, thank you very much. Is there anything else you'd like to mention?
Well, if I have a few minutes, I don't
Yes,
want to consume, too many cups of coffee. In reality, Microchip has a very broad portfolio of devices. In fact, we have, devices that are CPLD-like replacements in really tiny packages. We also have a low-density family, SmartFusion 2 and Igloo 2, that have a ton of resources at the lowest power. Really exciting time for us right now is the PolarFire family. So fully launched into production is the PolarFire FPGA family. This is targeted at mid-range applications, so 10 gigabit Ethernet up to 12.7 gig SerDes. These are, as small as 100,000 logic elements, as large as almost 500,000. So a lot of flexibility. These also have the smallest form factors. So, imagine a 10 gigabit Ethernet design that fits into an 11 by 11 package for an FPGA that supports DDR4. What's coming really soon this summer, and this is a big deal for Microchip, is our hardened SoC version of the PolarFire family. In fact, we will be the first commercially available RISC-V based multi-core programmable platform. I know that's a mouthful, but this is a really big deal for us.
Absolutely.
It's a 5-core RISC-V based SoC FPGA that can support bare metal, multiple operating systems, including real-time Linux. So the other plug, if I can get it in, is all of our product families, regardless of which one you want to look at, these have incredible power and thermal efficiencies. They're all non-volatile, so which means makes them live at power up. We offer defense-grade security, and we've really optimized these devices for those mid-range type of applications. We also have a suite of developer and design resources to make getting your next design to market simple, including hard and soft embedded processors. Our design software is called Libero SoC. I mentioned the VectorBlocks accelerator that's coming soon that'll help you make that leap into inferencing. Tons of development kits. From the Hello FPGA kit, that's about $150, out to what's pictured there is our Smart Embedded Vision kit that comes with, dual image sensors, lots of IP. And being part of Microchip is really exciting because we can offer you a faster time to market with validated clocks and power. So, we're working together to create, a system and a reference design that just makes it plug and play for the engineers. So lots of things for you to look at.
Cool.
You can go to www.microchip.com/hello FPGA or /PolarFire and learn more.
Thank you very much. So, Wayne, What questions do we have from the audience?
Wow.
Wow.
Let's see. It's a lot. It's a lot of work back here. I just want you to know.
Oh, yeah, so
I
much.
don't just sit here and look pretty,
Oof.
but I do look pretty.
That's for sure.
But
You do look pretty, though.
oh, thank you, as do you. So I have several questions actually. The first one is actually related to something you actually just answered about the IDE. So I just wanted to mention to everyone who's on the YouTube chat that I actually posted a link to the Libero IDE in the chat, just so they know.
Can I correct you, Wayne, on that?
Yes, you can.
Yeah, sure.
Correct you, Wayne. So we actually have two products.
Okay.
So we do have an Eclipse-based IDE called
Okay.
Soft Console.
Gotcha.
And so Soft Console is used to program in bare metal and C+ languages our processing architecture within our SoC-based FPGAs. The main development platform is called Libero SoC.
Gotcha.
So Soft Console is an add-in for that. But when you say IDE, I have to make sure that you're talking IDE, which that's Soft Console, and then the dev platform is Libero.
Yeah, definitely correct me. I'm an MCU guy, and I don't really. Yeah, this is all new to me. So I have a question from Juan, and I believe Juan's watching us on YouTube.
Cool.
As far as IP, how mature is your video IP? Can you handle 4K and 8K outputs? FPGAs alone can handle HD SDI signals. Is a question.
Okay, good questions there. So Juan, the answer is yes, we can support 4K image sensors. We are working on an 8K solution. Specifically for 4K, we support even the latest interface from Sony, which is SLV-SEC. Lots of flexibility. We have full MIPI CSI receive and transmit in our FPGAs. So we also have SDI. So I think he said HD SDI, if I'm not mistaken.
That's correct.
Okay, so we support up to 12 gig. So we have a 12 gig SDI solution. We actually have a FMC card that you can connect to one of our development boards to help you validate that. But lots of different IP. So bring it on. We'd love to see your design one.
Very cool. Very cool. Let's see. I'm going to switch over to a question from Umesh, also on YouTube. His question is, I'm trying to learn digital design with FPGA, and he's kind of looking, he's having a little bit of trouble programming a board, wondering where he could where he can get some help. And by the way, I have a cheat code here. I'm looking at our internal chat here, and our coworker Diptesh is doing great at helping and making sure we have the actual answers to the questions.
Thank you, Diptesh.
Well, for that, what I would first do is point you to our community forum. So we have multiple community forums that are hosted on microchip.com specific to FPGA questions. So you can seek help from your peers. We also have a tech support portal where you can, if you feel like you've maybe found a bug, you can log in a case in that respect. Also, as I mentioned, we're going to be hosting these entry-level, training classes that will leverage the Hello FPGA kit. So this will be a great way to get you started today on learning, the tool suite, getting some exposure to it, and having an instructor live, to ask questions to, as well as running through a lab. So you're going to actually have design experience as a result of these hands-on labs. We also have lots of videos available, on the website, on YouTube. We're constantly trying to build videos, especially, that we're all at home. You can see I'm at home. So, want to make learning the products and deploying the products easier for you. So
very cool.
Come check us out.
Very, very cool.
Yeah.
And by the way, Mia Lita wanted me to mention that there's a webinar that you guys are putting on July 21st and 22nd. And we have a registration site. I'm going to drop a link in there as soon as I can.
Cool.
Let's see. Ambroise Suter, and I'm sorry if I don't get your name correct, from LinkedIn, wants to know if there are any dedicated accelerators for AI or signal processing available in your FPGAs.
So interesting, dedicated accelerators. So if I kind of break that down in my mind, that would mean some of the resources that are pre-built. We have some optimized demos that are available. We also have connection into the Model Zoo, which is where you can download, some pre-optimized models to do, development with. This will all be part of VectorBlocks. And so, apologies if I'm butchering some of this. We will be having a VectorBlocks video available here in a couple of weeks. The webinar that they mentioned coming soon is also, an introduction to VectorBlocks. So hopefully that answers your question in a general way. And come watch some of the videos and webinars that we have coming up on that product.
Perfect. I got a softball question from Nick DeRosa, who was
nice.
our guest from a couple of weeks ago. He's like, do you have any design partners that focus on FPGA designs?
Ooh.
We have lots. So Microchip has a really robust design partner ecosystem and partner program. So Nick, you host that, so you should know. But the audience out there needs to know if you need help with your design, either a specific piece of the design or you want, full cradle to grave support, we have a design partner for you. The design partner page is live on microchip.com, and there's a secondary FPGA and SoC based design partner page where we have partnerships and experienced design partners that are, ready to take on, your next project.
Very, very cool. Very cool. And let's see. I think we're probably getting close to wrapping up on the questions here.
Okay.
If we didn't get to your question, you can actually send us an email and ask the question at livestream@microchip.com. And we will actually Clifford will personally get back to you.
I will personally get back to you.
One of us will personally get back to you.
Wayne will make me do it, don't worry.
Or there's the email address that Diane gave, hello FPGA. Is it FPGAs or FPGA?
FPGA.
Hello FPGA.
Hello FPGA at microchip.com.
Perfect.
And those of you who are interested in VectorBlocks, you can also send an email to VectorBlocks, VectorBlocks @microchip.com.
Cool.
Perfect.
Yeah.
And don't forget to check out that webinar. I'm going to post the registration link in 1 second, and just so everyone has it. And I think that let's see if we have any more questions in the chat before we close out.
Okay.
Let's see. So there's a question from Euless, and I may end up kind of butchering this question. I apologize, Euless, if I do. Is there a relation between Microchip and Imagination Technologies so we can use their GPUs with RISC-V? And Diptesh is kind of
good question that I don't know the answer to.
So Diptesh is kind of giving me a little bit of context here. He says not right now, but let's see. We're the first RISC-V based SoC FPGA in the industry, so that's basically just a point to mention there. And
so if you don't mind that I add on to that,
sure.
We have an ecosystem. So it's called Mi5. There is a huge ecosystem of partners from middleware and RTOSes to SOMs to debuggers, compilers, you name it. So there's a huge ecosystem of support around RISC-V. And then Microchip has their own ecosystem that we've been building out and doing a lot of reference design and platforms and partnership type of business relationships. So look for Mi5. If you don't find what you need there, or if you're a partner and you want to join the Mi5 ecosystem, reach out. We want to make this, broad. We want to make this, effective. We feel like we've got a lot of, commercial penetration for the partners that we have, but we're always looking for more.
Perfect. And this is awesome. I think that we're definitely gonna have you on for kind of a longer form discussion, maybe
sure.
maybe a bit of a longer Q&A, because it looks like everybody has lots of questions they'd love to ask here that are just to be able to pick your brain.
Yeah.
So. But for now, we're going to close it out. And Clifford, you've got I know you've got something to say here, because since we're on kind of episode, we're at the end of the pilot run here for this coffee break. So
as Wayne sort of alluded, this is going to be the season finale of Coffee Break. but luckily we've been picked up for a season 2. But what that means is we're going to take a month and a half off, and then we'll be back. We're planning on doing 6 shows in the same sort of cadence that we've been doing these. We're already working on getting people like Diane or anyone else to come on and talk with us. But if you guys have particular topics that you really want to see us deep dive, Microchip has a wealth of knowledgeable people that we can just pull from. But anyway, so keep in touch and watch out for that. I'd like to give a special thank you to Diane. Thank you very much for talking with us. And a big thank you.
Thanks for having me. This was fun.
Absolutely. Yeah, no, it was good. It was very, very good. Thank you to everybody behind the camera that was able to make this work. It takes a lot of hands, and thank you to the audience, because this wouldn't happen without you. But stay happy, stay healthy, and I'll talk to you in a month and a half. See you.
Absolutely.
Bye.
Bye.